Hi students, in this video we will be solving exercise 5.1 question number 26 from 2nd PUC syllabus, and the chapter is continuity and differentiability. The sum is on continuity. So we will be solving question number 26. This is a very important question. It has appeared more than 4 to 5 times in the Karnataka PU board exam. In part E, which will consist of two questions, 49 and question number 50. Question number 49 and question number 50 will be of 10 marks with two questions as 6 plus 4 marks. 4 mark and question will be from continuity. So it is a very important question. This can appear as a 4 marker question in question number 49B or 50B. So let us understand the question first. Find the value of k so that the function f of x, the function is defined like this, is continuous at x equal to pi by 2. As per the question, it is already given that the function is continuous at x equal to pi by 2. What we have to do is, there is a coefficient k or a constant k in the function. We have to find the value of k given the function continuous at x equal to pi by 2. As per data, the function f of x is continuous at x equal to pi by 2. So by definition, we'll use the definition of continuity now, because it is clearly mentioned that the function is continuous at x equal to pi by 2. What is the condition for a function to be continuous? The left hand limit, right hand limit should be equal to value of the function at that particular point where the continuity is being discussed. If we are discussing the continuity at point A, then LHL and RHL at that particular point should be equal. That means limit of the function should exist as x tends to A, and that limit value should be equal to f of A. So this is the condition for a function to be continuous. Now we are using that condition for finding the value of k. Now limit of f of x as x tends to pi by 2. If this limit exists and the value of that limit is equal to f of pi by 2, then the function is continuous. As per the definition, it is already continuous. So this should hold good. So we are using this condition and calling this as equation 1. Now let us check how the function is defined. At x equal to pi by 2, the function is 3. Correct? F of x will be 3. For all the value of the domain x except pi by 2, the function is defined like this. F of x will be k into cos x by pi minus 2x. Now, as per data, f of pi by 2 is equal to 3. Correct? So, now this part is clear now. We have to evaluate the limit of the function. So limit of f of x as x tends to pi by 2 is equal to limit of k cos x by pi minus 2x as x tends to pi by 2. Now the moment you substitute pi by 2 for x in this expression, it takes an indeterminate form, which is 0 by 0. So it is not defined at x equal to pi by 2. So it takes the indeterminate form. Now we have to evaluate the limit by eliminating the indeterminate form. So limit of f of x as x tends to pi by 2, this is what it is. Whenever there is a trigonometric function and the limit is tending to a non-zero value, then we can solve this by substitution method. And what should be the substitution? Yes, if x is tending to pi by 2, then substitution is always like pi by 2 minus x is equal to some t. That is what we always make. Limit minus that x is equal to t. This is what is the substitution. So pi by 2 minus x is equal to t. Now what is x then? If this is the substitution, then it is pi by 2 minus t. Correct? From this substitution only. Okay, this is clear now. Now when we make the substitution, we have learned in our first PU limits chapter that whenever you substitute, we always have to change the limit accordingly. So as x tends to pi by 2, what does t tend to? Look at this expression, pi by 2 minus x is equal to t. That is, x is tending to pi by 2. No, it is not equal to, it is tending to pi by 2. So if you just check the value of t, then by substituting x equal to pi by 2, it will tend to 0. So as x tends to pi by 2, t tends to 0. So let us all use this substitution and limit in the expression. So limit of k into cos of x. X is pi by 2 minus t. Correct? We will substitute that. Cos of pi by 2 minus t divided by pi minus 2 into, in place of x again pi by 2 minus t. Now limit also has to be changed. That is, t is tending to 0. Now look at the numerator term, cos of pi by 2 minus t. cos of pi by 2 minus theta is sin theta. How do we know that? Pi by 2 minus theta is an acute angle in the first quadrant. In first quadrant, all trigonometric functions are positive, so is cos function. So pi by 2 minus theta, and the angle is expressed in terms of pi by 2. So trigonometric function changes to its cofunction. So cos of the function changes to sin theta. So numerator will be k into limit as t tends to 0 of sin t divided by, we will open the brackets by multiplying by 2. So pi minus pi plus 2t as t tending to 0. Since this is a constant and a coefficient which can be kept outside the limit. So pi and minus pi gets cancelled. That would be equal to k into limit of sin t by 2t as t tends to 0. If you look at the angle, it is t, and what we have in the denominator is 2t. So use the standard form. For that, we need to take out this half, which is this 2 in the denominator. We will keep it outside the limit as k by 2 into limit as t tends to 0 of sin t by t. That is, we have learned a standard form in our first PU limits chapter, that is limit of sin y by y as y tends to 0 is equal to 1. So this whole term, limit of sin t by t as t tends to 0 is equal to 1. So the limit will be k by 2. We have used the definition of the continuity of a function and we have called it as equation 1 also. So we will apply here. This part we know it as 3. The limit of this function we got it to be k by 2. So we will equate those two. K by 2 is equal to 3 and k is equal to 6. So this is the value of k when the function is continuous at pi by 2. This is a very important sum. Please do learn it properly. You write, you understand, solve on your own, then it will be easy for you to remember